Okay, on notes 8.1, we're going to be looking at quadratic functions and their transformations. So number 1, we're looking at the quadratic parent function, f of x equals x squared. So that's the quadratic parent function. So we're going to be using that throughout the lesson. The points that we will use if we plug in a -3 and we square it, we get positive 9. -2 squared would be 4. -1 squared would be 1. 0 squared, 0. 1 squared, 1. 2 squared, 4. And 3 squared, 9. Okay? Alright, so let's plot those points. -3, 9. -2, 4. -1, 1. 0, 0. 1, 1. 2, 4. And 3, 9. There's our quadratic parent function, f of x equals x squared. The domain, we've talked about before, the domain of any parabola that opens up or down is all real numbers. Because if you look at the x-axis, it's continuous both directions. So we could plug in any real number in for x and get an output, which would be our y. So domain is all real. And then your range, if you look at the y-axis, the only y values that are being used are positive values. So y is greater than or equal to 0. The reason for that is because when you're squaring something, you're always going to get a positive output there. Okay, so we're going to be using that parent function throughout. So on the next part, we're going to be describing the transformations of each quadratic function, and then you're going to sketch the graph. So we've actually gone over this before. Anytime we put a negative in front of our parent function, that's going to reflect across the x-axis. So our vertex will not change, so our vertex will still be at the origin, and then everything that changes are our y values. They're negatives instead of positives. So instead of having -3, positive 9, you're going to have -3, -9. -2, -4, -1, -1, 1, -1, 2, -4, and 3, -9. So you're using those points from the parent function to graph the other functions that we're going to be looking at. Okay, so on 3, notice it says h of x, that's just another function notation, equals x plus 2 squared. So if you remember back whenever we were looking at vertex form of a parabola, that was A, that's your vertex form, h was your x value of the vertex, k was your y value. So anytime it's inside parentheses, it's going to be shifting left or right. If it's plus, it's going to be shifting to the left. So this will shift to the left too. So our vertex will shift. It's normally at 0, 0, so I'm going to shift it left 2. There's my new vertex. I'm acting like that is still the origin, and I'm going to plot the same points that we had on our parent function. So from that point, I'm going to go right 1, up 1, because the point 1, 1, and then right 2, up 4 from that point. Right 3, up 9, and then the same thing on the other side. Okay, so if you're shifting, you're going to be shifting the vertex. So always shift the vertex, and then you can plot the same points that we have on the parent function. Okay, if we look at 4, notice we have parentheses, and this time it says x minus 2. If it's subtracting inside the parentheses, you're going to be shifting to the right. So that would be right 2. So vertex going to the right 2. Everything else stays the same, so we're acting like that's our new origin. So 1, 1, 2, 4, 3, 9. And then same thing on the other side of your vertex. So there's your parabola. Okay, so you have to know your parent function, f of x equals x squared. You need to know the points, so that way you're able to plot them whenever you need to translate. All right, 5. We have g of x equals x squared plus 2. So notice there's not any parentheses here. If there's not any parentheses and you're adding and subtracting on the outside or after your x squared, then that will be a vertical shift. So if it's plus 2, we're going to be going up 2. So we're going to shift our vertex up 2. And then we're acting like that's our new origin, so we're plotting the same points from our parent function. So right 1 up 1 from that new vertex, right 2 up 4, and then right 3 up 9, we go off the graph, so those are the only points on that side, and then we'll do the same thing on the other side. So there's your new parabola. Alright, so notice 6, we don't have parentheses, and then it says minus 2, so that will be going down 2. So shift your vertex down 2, and then points are the same. Right 1 up 1, right 2 up 4, and then right 3 up 9. You can plot that one, and then same thing on the other side of your vertex or axis of symmetry if you want to draw that. Okay, so number 7, notice that we don't have anything that we're adding or subtracting, but we do change our a, which is the coefficient of x squared. Notice that a is 2, your coefficient. So if a is greater than 1, you're going to have a stretch by whatever that coefficient is, so stretch by 2. My vertex will not change if we don't have a plus or a minus sign. Okay, so my vertex is going to stay at the origin because we're not shifting it. Now, whenever you have a stretch or a shrink, you're having to multiply your y values by whatever that coefficient is. So I'm just going to write my parent function chart here that we looked at on the front. Negative 3, 9. Negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. Okay, so you're basically just multiplying that y value by whatever that new coefficient is. So we're having to multiply the 9 times 2, which would give you 18, which will go off the graph. Multiply the second y value by 2, that's going to be 8. You get 2. Notice this one stays because we're not changing that vertex. Okay, so we're plotting those points, so you can look at the positive ones or negative ones. So we have 1, 2. So instead of going right 1 up 1, you're going right 1 up 2 because you're having to multiply by 2. And then instead of right 2 up 4, we're going right 2 up 8. And then same thing on the other side. So it makes the parabola narrower whenever that a is in between or is greater than 1. So you're just having to multiply your original y values by whatever that new coefficient is. So if you look at 8, notice your a, your coefficient of x squared is 1/2. So anytime it's in between 0 and 1, it's going to be a shrink. Put a there. So shrink by 1/2. So my vertex is not going to change. We don't have a shift. Instead of it being 1, 1, it's going to be 1/2. Instead of it being 2, 4, it's going to be 2, 2, because you're taking half of that original y value. And then instead of it being 3, 9, it's going to be 3, and then half of 9 would be 4.5. And then same thing on your other side. So it makes the parabola wider because those y values are shrinking, getting smaller. Okay, now we're going to summarize everything. If you have a negative, in front of the x squared or your parent function, it's going to reflect across the x-axis. If you have x plus h inside parentheses, then it's going to shift left h units. If it's minus inside parentheses, it's shifting to the right h units. If there's no parenthesis and after your parent function x squared, it's plus k. That means you're going to be shifting up k units. And then minus k will go down k units. Okay, if a changes, if a is not 1, if a is greater than 1, you have a stretch. If a is in between 0 and 1, you have a shrink. Okay, so those are things that you need to know on your transformations in order to graph your new function. Okay, so on 15, you're going to be given multiple transformations from your parent function, but we're always starting with our parent function, f of x equals x squared. Okay, so I want you to write your transformations down first, and then you can find your new function. So the negative in front will reflect it. Inside parentheses, you have x minus 3, so that will be a shift to the right. So right 3. And then the plus 1 on the outside of the parentheses, you're going to be going up. So up 1. Notice that we have a table here for our parent function. So we're just filling in those points that we talked about on number 1. So negative 3, 9, negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4, 3, 9. Okay, so what you need to do first at the very beginning is shift your vertex wherever you need to shift it. So notice that it says right 3 up 1. So from the origin, go right 3 up 1. There's your new vertex. From here, we're acting like that's the origin, and we're plotting those points from our parent function. But notice that it also says reflect, which means your y values are going to be negative because you're having to reflect over the x-axis. So that will end up being a negative 9 there, negative 4, negative 1, that'll stay as 0, and then negative 1, negative 4, and negative 9. So it'll open down now. So negative 3 from this new point, left 3 down 9, and then left 2 down 4, left 1 down 1, and then the same thing on the other side. So there's our graph. Domain of any parabola is all real numbers. And then your range, if you look at the y-axis, this y value is 1, and it's everything below it. So y would be less than or equal to positive 1. Okay, 16. Here's our parent function. Fill in the table again. Okay, so write down your transformations. This 2 is going to be a stretch. The x plus 4 is left 4. And then the minus 2, you'll shift down 2. Okay, so at the very beginning, go ahead and shift your vertex. So it's going left 4, down 2 from the origin. So there's our new vertex. And then once we've done that, then we're going to have to worry about this stretch by 2. So remember we talked about to stretch it, you're just multiplying by that number on your y values. So that'll be 18, which will go off the graph. That doesn't change. Alright, so we're plotting the points from our new origin, which is our vertex. Negative 3, 18 goes off the graph. Negative 2, 8. Negative 1, 2. 1, 2. And 2, 8. So we're just having to double our original y values. Multiply it by 2. So domain, all real numbers. Look at your y-axis for your range. That smallest y value, that's a negative 2 there, and it's everything above it. So y would have to be greater than or equal to negative 2. Okay, so on those examples we were given the function, we wrote the transformations, and then we graphed our new function. On this next part, we're going to start with our parent function, f of x equals x squared, and then we're going to write the new function by giving the transformations. So all of these, we're writing the equation, it says, so I want you to, I'll just call it function g on every single one, but you need to have an equal sign, either y equals, g of x equals, f of x equals. Okay, so we're starting with x squared. We're shifting 3 units to the left. So that means you need parentheses and you should be subtracting. Or adding, my bad. So you're going to have x plus 3. Don't forget the squared on the outside of the parentheses. If you forgot the squared, it would be linear. And then you're going down 6, so minus 6. Okay, the next one we're reflecting over the x-axis, so that makes a negative in front. Stretching by a factor of 3, so that's your coefficient of your x squared. We don't need parentheses, we don't need any pluses or minuses because we're not shifting left, right, up, or down. (19) we're shrinking by a factor of a half, so that's my coefficient of x squared. You're shifting to the right 3, so that would be x minus 3 squared. Don't forget the squared on the outside of the parentheses. And then going up 2, so plus 2. (20) we're reflecting across the x-axis, so negative, stretch by a factor of 2, so that's your coefficient. Shifts 2 units to the right, so in parentheses you're going to have x minus 2. And then don't forget the squared. And then up 3 would be plus 3 on the outside of the parentheses. Okay, last one. We're not given the transformations. We're just given a graph. So you need to write down your transformations, and that will help you find your function. So notice it's opening down, so that's going to be a reflection. And then find what's happening to your vertex. So from the origin, you're going right 1, 2, 3, 4, and up 3. Check your points. From your vertex, you're going right 1, down 1, right 2, down 4, so those numbers aren't changing other than the reflection. So negative in front, x minus 4, because we're going to the right. Don't forget the squared, and then plus 3. Okay, so you need to make sure that you remember what the quadratic parent function is and also what those points are. We will talk about a different type of function tomorrow.